Our next speaker has an impressive academic record. He has earned multiple master's degrees in engineering, in computer science, telecommunications engineering, and image treatment, and CAD design. He also holds an MBA from IMD Business School in Lausanne. He currently leads a global department with expertise in artificial intelligence, machine learning, software development, automation, and simulation. Please welcome the General Manager and Global Head of Industrial Computing at Siemens Digital Industries Factory Automation, Thibault de Assi. Hello, Thibault.
Hello, thank you very much.
Good to see you. We can see you. We can hear you. The floor is yours.
Perfect. Look around you. Look at the assets around you. Your mobile phone, your production machine, your robotic station. 85%. Huge number. 85% of potential assets remain unconnected. Yet, 87% of machine learning projects never make it into production. There will be 41.6 billion industrial IoT devices in 5 years from now. I cannot see your faces. Unfortunately, I wasn't able to come to join you in Berlin. And I am sure you are wondering how we Siemens are helping our clients in connecting, in protecting, and in turning data into valuable insights. And to answer to that question, I'm here with you today, Thibault de Assi. When we help our customers in their journey, we really take the time. We really take the time to understand their pain points, to really understand the data flow across the whole value chain, and to really understand how operational technology layer is integrated with information technology layer. And then we bring our hardware and software integrated solution together with our industry know-how and our machine learning experts to answer to our clients' challenges. It all starts with data. There is different data sources in the shop floor. And from there, take a look at the circle and take a look at the left side of the circle. From there, we're gonna create an AI model. But this is not enough. Take a look now at the right side of the circle. From there, we're gonna create a software with domain know-how, including a human-machine interface, helping operators to take the right decision. But that's also not enough. We need to execute that software application on an industrial grade hardware. And for that, we need an industrial PC. We need an edge devices to realize customer value. We at Siemens, we are also offering in operation to manage the AI lifecycle, from connectivity to deployment to monitoring and training. And now, take a look at the bottom of that slide. That could be your power plants. That could be your production machine. That could be the elevator that take you to the Berlin conference or to your home this morning. On top of it, we have what we call the control layer. This is where with the industrial PCs or with the PLC, with the controller, are controlling those field devices. Then we have our edge layer. And for us, edge is not a simple gateway. For us, edge is about connectivity. It's about openness. It's about local data pre-processing. It's also about data and security. because security is at the heart, is at the core of our product portfolio. And it's about machine learning and artificial intelligence. The layer above is the cloud layer. With our platform MindSphere and with Mendix, we are offering to our clients an efficient way to develop their own industrial IoT applications and deploy those applications in the OT on the edge and on the edge layer. This is an example of a body shop. This is the whole ecosystem. At the left side of the screen, the number one, this is where we have the automation, the control layer with our thematic products or other third-party products. Then we have the edge computing. This is our edge devices, the industrial grade hardware, where we are running AI application and non-AI application close to the machine. It's a cloud agnostic. And then we have an edge management system. This is a centralized management system for mass updates, for security updates, and for distributing application across the whole manufacturing line. We have also an app store enabling our partners, but also Siemens, to provide AI and non-AI application and enabling to deploy those applications on the shop floor. These are use cases where we are developing and creating impact with AI at our customer side in different industries. Take a look at the second use case in the first row. Smart assistant, Siri. I'm sure you have been using Siri to find the nearest French restaurant. Uber is becoming a verb today. We have Sam. Sam thematic assistant for machine. It embeds natural language processing and knowledge graph, enabling the field maintenance engineer to communicate and to collect data from the machine and to execute its maintenance of a procedure in an efficient manner. Let's take a look on some of those use cases that we have been implementing in the industry. The first one is about defect prediction for die casting. Today, our customers are inspecting the parts at the end of the line. He's looking at the part manually, or he is using automatic optical inspection. He is scrapping more than 10,000 parts per year. A defect rate between 2 to 4%. At other customers, it can go up to 10%. What we have been doing here, we have been identifying key process parameters affecting the throughput of the die casting machine. We build an AI model and we deploy that model on our edge devices to make real-time anomaly detection and defect prediction and feedback that result to the PLC to prevent further production of defective parts. It helped our customer to further reduce the process costs and defective products by 30%. And you managed to optimize the process and decrease the defect rate by 40%. And I am sure in your own words, you also would like to have such savings. Let's have a look on the architecture. So we are collecting data with our thematic S7, the controller, what you see on the left side of the screen. Also additional data coming from different quality data, coming from quality management system and other sources. This data is fed into our edge platform that run on our edge devices. There we have our trained AI model for clustering and classification purposes. With the data, we have also a storage. And from there, we have also dashboard. This is where the operator can observe the data to take some decisions that would impact the die casting process in this case. We have also a cloud gateway to send the data to the clouds for data storage, further statistical analysis, training purposes, and later on deployment. The second use case is coming from the bakery line. It's about visual quality inspection. The baked product is ejected out of the oven on a conveyor belt down to the packaging line. Today, our customers are counting manually the baked items. The defects also could come from the degree of burn or the size of the shape of the items. So what we have been doing, we have been implementing an imaging system to get a near accurate count of the baked items, to localize the defects that might happen after at the end of the oven. This data would be sent to the PLC, where we have our AI model running there, and through the HMI we would be able to look if these baked items has good or bad quality. It helped our customer to save time in inspection, to improve or reduce inaccuracy in the counting area, and to reduce defects. The third use case is about visual inspection in additive manufacturing. A BioJet 3D printing is the additive manufacturing technology for making or for printing a product out of a digital file or out of a CAD file. This process could go up to 2,500 layers per job. It could last 30 hours to get the product printed. And what we have been doing here, we have been implementing a vision system to detect defects layer per layer. In case of defect, it triggers a stop signal for the printing machine. The operator could take out the product, take some measures, either put it back or discard it, and run another manufacturing cycle. It helped our customer to reduce time and rework around 2.5 hours per day. The fourth use case is about failure prediction for automatic guided vehicles. Today, at this customer, AGVs are being charged at the end of the manufacturing cycle. One stop of a single AGV results in 500 euro per minute. 500 euro per minute production cost. Our approach was to analyze AGV alarms from the reports, getting data from the charging stations, and develop an AI model to predict accurately when the maintenance has to be done. And this helped our clients to avoid stop in the operations, reduce production costs, and optimize the charging processes. Here you have, from architecture standpoint, how this would work. We have the AGVs, they have a controller. We collect the data from the AGV controllers. This data will be sent to an edge devices, where we have our AI model running there, monitoring system that provide the information. When do we have to send the data? When do we have to send the AGV to the charging stations? The fifth use case is about process optimization. It's about improving beer quality. I'm sure you love drinking beers. I do. So today, there is a kind of inconsistency per batch. Process parameters are influencing the beer quality at the end of line. And there is a kind of a beer sommelier after the packaging who is testing the beers and associating grades. And the minimum grade, it has to be 6.8. What we have been doing here, we have been identifying key process parameters influencing the beer quality. If you look at the overall process, we have raw material, brewing, cold block and fermentation, packaging, quality check. Parameters like time, pH value, alarms, yeast type in the fermentation area, dosing data in the fermentation, quality, energy, and so on. These are the parameters that have huge influence on the manufacturing processes. And we developed the AI-based solution to predict parameters for achieving such optimized process to get the right quality at the end of line. And we observe the trend. How we get to this 6.8 grade. And we correlate all processes together to achieve that result. We develop the model, and we train that model on the edge, as you can see here. This helped our customer to improve processes, to optimize his processes, but also to improve the quality of the product coming from its own supplier. The last 6 use case is coming from our electronic plants, from our Hamburg plants. Today, to inspect PCBs, we are using a very expensive machine, X-ray machines. What we have been doing there, we have been gathering data. We have been gathering data from the different process areas in the PCB manufacturing plant, from the solder paste printer, from the solder paste inspection, from the pick and place machine, from the ovens, from the automatic OI inspections. We developed the AI model. Data are being sent to our cloud platform, to our MindSphere. And this AI model being trained with a software application deployed and run on the edge. And there we would be able to predict the quality of our PCBs. It helped us to achieve 30% fewer X-ray tests. It helped us to achieve 100% quality rate and reduce our capital investment by $500,000. We have our software and we have our industrial grade hardware to help our customers to deploy and run those use cases. From the ultra compact, the failless device, what you see on the left side of the screen, this is where we have been running our additive manufacturing use cases. The embedded, this is where we have been running our AGVs, and the high end, when it comes to a real-time quality inspection for high-end images or for training data on premise, this is where you would require such powerful devices. AI is one of the major breakthrough technology in our century. AI enabled us to trigger tasks that a human being are not able to do before. AI is providing the right information, the right data to the operators, helping him to take the right decision. How do we imagine AI in 2030? I do see smart assistants. Those smart assistants getting data from different sources, from the operational technologies, but also from the informational technology, providing that information to the operators to perform efficiently and take the right decision on the shop floor. I do see AGVs optimizing the routes by themselves within the factories. I do see more and more factories going into autonomous factories. I do see robots with more and more vision embedded system with AI technology, being able to handle different parts, different geometries. So AI will bring a lot of productivity, efficiency, developing our own people to put us at the next level in terms of manufacturing and in terms of industry. And now, before going to Q&A, And when I say go, and not until I say go, I want you all to go to the chat room. I want you all to the chat room, to go into the chat room and write one word, and one word only. So now, look around you and imagine an object. Imagine an object that can be your smartphone, your kitchen appliance, that was produced using artificial intelligence. Ready? Go to the chat and type it.
Thibault, thank you very much.
Thank you.
Thanks a lot. Thank you very much for your energy and your passion. And I'm not sure if our audience has seen it, but you have also prepared a couple of questions in the poll section of the Swapcard app. So I would ask you all to look at these polls and please give us your answers so we can talk a little about that.
Maybe I want to build on some of the colleagues that are posting some words in the chat. So for example, Dr. Nico Erdmann, he mentioned car, and absolutely here in the welding, in the body shop, in the welding process, we are applying artificial intelligence to improve the quality of the spot welding. Thank you, Dr. Erdmann, for your contribution.
Right. We will. I think we will see how the polls change over the next couple of minutes. I just want to ask you something. You gave us such a broad portfolio of things that are possible, that can be done with your technology, or technology, maybe not from Siemens, but preferably so. I have the feeling that there is something in there for every manufacturer. Do I understand that right? Would you say that it is a fool who manufactures anything and is not looking at the possibilities today?
In fact, we from the digital industry, we are addressing a broad range of verticals. So we are in automotive, we are in food and beverage, we're in electronics, batteries, also within the process industry, in the pharmaceutical, in the chemical industry. So I would say we have the right industrial portfolio to help our clients to take advantage out of AI.
Right. Okay, thank you. Let us look maybe at the answers of the polls now and see if anything surprises you. For instance, nobody voted for batteries being benefited by artificial intelligence. Most people settle on automotive and logistics. Most of the people are not at all using AI solutions on the shop floor yet. I'm not sure if this is like a problem of our audience, or is this something you encounter very often, that people say, very interesting, but we don't do anything at all, and we probably don't have any particular plans at the moment?
Yeah, I mean, absolutely. I mean, actually, if we look to overall customers that we are helping them today, I would say we have around 50% of those customers that are running a proof of concept on the shop floor. Mm-hmm. I would say 30% they are really forging ahead in terms of implementing and taking advantages, and 20% to 30% they have no idea. Said, you know what? We know a little bit about AI here and there. How you, Siemens, could help us to really take advantage out of artificial intelligence. And from a customer perspective, we do see, I would say, different buckets. The one who has its own experts and on AI, and they are looking for industrial grade solution, software and hardware. The ones who want to partner with us, and the ones who are asking us for a machine learning key expert in combination with our Siemens hardware and software portfolio elements.
Right. Apart from the industries that you mentioned now, do you see the possibility that in some completely different fields of industry, suddenly there will be a lot of benefits and gains and we're not thinking about it yet because maybe technology hasn't evolved enough?
Yeah, I mean, absolutely. I mean, I was, for example, at one customer. He was doing is an ice cream manufacturer, and guess what? He wants to apply AI to improve the quality of the images that is on the packaging line. Mm-hmm. So what happened today is that it's a manual activity, right? Is where we have the operator carrying big boxes of big samples of those ice cream packaging of ice cream, and they are inspecting manually. So we do see in a lot of fields, right? AI could really bring value in there. In the appliance, for the kitchen appliance, right? We also see a lot of, in the consumer world, a lot of AI in there.
Right, thank you. When we look at the question, what keeps companies away from implementing AI on the shop floor, there are top two, maybe, yeah, the third one is also very close. Like the top two reasons is lack of trust regarding AI solutions and insufficient AI expertise for creating and deploying AI models. How do you think these, first of all, do you think these concerns are merited and how could you work against them?
Absolutely. And first of all, regarding trust, I think my colleague Uli Waltinger, he will have a session around trustworthy AI, and he's gonna talk about this theme very deep in this event. What we do see today is two things. First is lack of trust means how my AI, am I gonna be sure that my AI model would be performing as expected in the shop floor? And here come, I would say, our expertise, our industry know-how, right? Together with our partners, with our clients, because they know their machine, they know their process better than us. And bringing our experts together with them, we would be able to monitor accurately the behavior of the AI model. And in case of drifting, right, of the performance, then we would retrain the model with more and more data to make sure that the model is performing accurately. The first point. Second point is, yes, absolutely right. There is a clear lack of expertise. I was hearing also the colleagues regarding quantum computing. Probably it's not at that scale, but actually there is a lack of expertise specifically in the industry when it comes to machine learning and AI. If you look to companies like Google and Facebook, you can have a lot of these high potential people in there, but in the industry is still a little bit there is still a lot of lack.
Right, thank you. The third biggest hindrance the audience sees is keeping AI solutions updated according to production changes. Frankly, that surprises me. I would not think that it is so hard. What is your take on that? Do you have experience? Is it hard to keep the thing updated, or is it easier than people fear?
Absolutely, and I also I totally share the feedback from the audience. I mean, assets are the behavior of the assets, right? Is being changed, and here comes technologies and software and hardware being able, let's say, to look at the assets behavior that would impact at the end the whole process, right? And here our solution in terms of monitoring the AI model, right? It's crucial to be able to get closer to our customers and provide additional services to improve the AI model and bring it back on track.
Right. Thank you. Maybe yes, please.
Sorry, I want to build back to the example of the beer, right? You have beer are being produced per batches, so quality, the raw material quality would have massive impact on the overall quality of the beer at the end of line, right? The raw material quality, the meal gap, the malt batch, and so on. So this is also an important element that contributes to the mistrust of the performance of the AI model.
Right. Thank you, Thibault. Maybe just a rule of thumb from your experience. When companies invest now in solutions like you propose them, when does it pay off? Right. So when do they have a return on invest? How long does it take for them to clap themselves on the shoulder and say, "Well, I've done the right thing"?
I would say it depends. It depends from customer to customer, industry to industry. So for some of the customer that I mentioned, or some of the use cases that I highlighted before, we do see a payoff after a period between 6 to 12 months. And here it all depends. For us, our approach is really working together as a partner with our clients. So here we need to both together align on expectation, align on KPI, bringing knowledge from both parties in order to achieve such return.
Right. Thank you very much. So let me pat you on the shoulder, Thibault. Thank you very much for your talk. And I hope you have a lot of success convincing people. But I think with that much energy that you have, it won't be a problem at all. Thank you very much.
Thank you so much. See you hopefully next year on stage. Thanks a lot. Have a good day.
Bye-bye. Au revoir.